So good evening, everyone. How are you today?
Good evening, sir.
So today we are going to be doing something deep, and what we're going to be looking at is how to analyze statistical data using Excel. I'm very sure that in one time in your life you must have done something statistic, introduction to statistics, descriptive statistics, inferential statistics, sometimes in your 100 level and whatsoever. So, and also when you get to final year, you will do what is called projects. And during that period, you have your methodology, and after you have your data analysis section, which always chapter 4, where you do your recommendation. So you are going to do a research. And within that period, you are going to sometimes people do questionnaires, sometimes people do primary data, which is questionnaire. Some people go with secondary data with data that are already existing. So you were going to be hearing median mode when doing that. It's something very, very, very common. We must have, some of us did it when we are doing mathematics, statistics, you see mean, median mode, group and ungroup and all that. So we can also make use of Excel to do this. So I would let me share my screen as we continue. So so kindly pay attention to this. So if you look at my screen, if you can see my screen, can somebody say yes?
Yes.
Okay, now statistical
Yes.
analysis in Excel.
Yes.
Statistical analysis in Excel. So statistical analysis. Now there is analysis, but there's statistical analysis. So analysis that just deals with normal and a description of a particular numbers is data analysis. But when it talks to statistical analysis, there are conditions that these have to be. So it is called statistical. Therefore, there are statistical terms we need to understand from this place. So analysis still remain analysis. So in Excel, so we want to perform a statistical analysis in Excel. And I'm very sure some of us don't like hearing this. Some of us hate statistics when we are in your 100 level. Can I hear you say something? Beatrice is smiling. Who else? Who else? Can you say something? Beatrice, would you have anything to say?
Oh, well, sir, it's not like I hated the subject. I mean the course particularly. It's just that the lecturer was like it didn't please him. So automatically, I just wasn't into it. But right here with you, Mr. Harry, I I think I will just like accept it. Yes.
Okay, who else want to have anything? Who have anything to say? Who else have anything to say?
Sir, hi.
Okay, Namdi.
Sir. Yeah. I think statistics is a very interesting course, actually, but because that is what I combined with computer science.
Oh,
Initially, when we got admitted, we are afraid of statistics. But at the time, when we started attending the lectures, we see that it's a very interesting part. Some of us had to switch to major on statistics because of how interesting it counts. But initially, people used to fear because of the mathematical aspect and a lot of it. But when you go deeper, you see that it's a very interesting course.
all right, thank you. I promise you that there's going to be an impartation of this, everything about statistics. Today, you understand it. This is one of the strongest core I major statistics. Okay, so I will explain it one after the other and the application of Excel into statistics. So many times, the things you do with your hands, the things you do with your formulas, the one you cram and all that, we don't need to do that. We're just going to follow a command and we are going to do it here. But I would like us to listen very careful to know the conditions that you need to have at the back of your mind before you make use of any of this. I study pure and applied mathematics and statistics, and by God's grace, I've been doing that for all my life, and it is going to be very simple for us. Even if you don't have the background, don't be scared. Don't be like, oh, they've come again. No, please, just go with us. We'll explain it, and you will understand. So that is it. So we'll go through this one after the other. So we have a data set, and the data set is talking about the student study hours and exam scores. So in statistics majorly, we always trying to establish a fact. Now, many of the facts we need to establish, sometimes when you look at the figures, when you look at the arrays of data, you cannot say this and this. Even if you can't go in depth to explain what is behind the performance of those figures. So in statistics, when we look at figures, we want to know something that makes about that figure. Now we have a data set, and the data set is student study hours, and the exam. We have this gender also. So in this kind of data, we might want to look at it and say, does it mean that the student studying hour correlates or has not something to do with their good performance? Okay, can we say that there is no really something relative to the study hour? So the student can pass their exams, they can have their good scores irrespective of the hour they are able to read. That is one. Two, we can also look at it that their performance, is it gender relative? Can we say that, oh, it is the female that passed very well, or oh, the male passed very well? So we want to establish a fact here. So we want to do something with our Excel. The first thing is we can get a descriptive statistics of this data. Look at it here using our Excel. We're going to show you very simple. After that, we look at that, we explain what the figures are. Then we are going to look at the correlation. The word correlation in statistics means relationship. Is there any relationship? But we'll go to that one after the other. So we look at relationship between two things. Okay, I want to look at that. And three, we're going to look at regression. So regression is talking about the estimation relationship between a particular variable. Why one is dependent, why one is independent. So that's regression for you. So where correlation is dependent, both dependent variables. Fine. Then after that, we are going to look at the t-test. The t-test. So this t-test is, there's a condition why you make use of t-test. When the numbers of value you have is less than or equals to 30. If the count is less than or equals to 30, so you make use of t-test. What is the meaning of t-test? It is when you want to compare two things, two means. Maybe you have country A, country B. What is their mean? The mean of country A is 1. The mean of country B is 1, 2. Because it is 1 and 2, there might not be difference between that. So it is t-test that will tell us, oh, because it is 1, this one is 1, and this one is 3. Doesn't mean they are different. They are the same. So statistically, we can show there's a significant, there's no significance or between these two means. So there are conditions we need to look at, and I'm going to spell that out one after the other. If you are here with me, can you say hi?
Hi.
Okay. Can we go on now?
Hi.
So great. So let's move on I know we all have the data with us, and we need to look at that. So I'm going to screenshot those, minimize my, I'll minimize, okay, sorry, let me minimize my table, okay, because I want to make use of, okay, can we all see that? So I have this. So fine, this is the data set. I know we all have the data set now. This is the data set. Can you see my screen? Can you all see my screen? Oh, God. Can you
Yes,
Yes,
we
see my
can
sir.
see your
screen?
screen. Yes, sir, we can see
Okay,
your
Yeah, I
now,
screen.
see it, but we
so
don't
the
have the
first,
data set.
yeah, they've sent the materials to you. So you can copy the data set for your by yourself.
The
You can
PDF I'm having, no.
What?
Only the PDF. I don't have the Excel.
There's no
many.
Excel.
It's only
Just
one
the data set.
material
You
they
can
sent
copy
us.
the data set up. Hello? The PDF is having data set inside. You can copy that. This is the data set here. This is the data set here. Can we all see that?
Okay, yeah.
Hello?
Okay.
Yeah, yeah.
This
Yes,
is
we
the
are
data
seeing it.
set here. So what you can do is this. When you copy your PDF, you can copy PDF to your Excel. When you copy it, you just place it here and click here. It will copy. When you copy, you can do whatsoever you want to do. Or you can type in. Just type in your for information. So you have the student, you have the working hours, study hours, sorry, you have the exam score, and you have the gender. So can we go on?
Yes, sir.
God.
Yes, yes.
So now we want to look at the first one, which is the descriptive statistics. So from the word describe, it means describing. From the word, this is just from describing. So the descriptive statistics. So what we are what is saying here is that describing the information you have. So descriptive, when we look at descriptive in statistics, we mean that the summarizing of data using your mean, your median, your standard deviation, and the range to provide a quick overview of the data set characteristics. So when we make use of this, it's called descriptive statistics. So when you study statistics, there will be a time you will do this as a course. So what you'll be doing is how to make use of your mean, your median, your standard deviation, and your range to summarize your data in order to provide a quick overview of the data set characteristics. So when you look at this data now, you can't tell me or you can't say what the characteristics look like. So with descriptive statistics, we can find out what the data looks like. So how do you make use of this in your Excel? So now we want to look at what is the characteristics. So we can check the characteristics of the student number. This is not necessary. This is just serial numbers of the student. 1, 2, 3, 4. This is working hour, the study hours. We can. This is the exam scores. We can. This is gender. We can. So you can't find the descriptive statistic of a spring data. What is called a spring data means text. You can't find you can only code it. So when you code it, recode, that's when you can do that. So when it is a data like this, you can. But somebody can say, why can't we find the mean of this gender? No, you can only find the mean of a figure data set like this. So we want to look at the descriptive statistics of exam scores. So from there, we'll find out the mean, we'll find out the median, we'll find out the standard deviation and the range. So Excel can do that for us. So how do we do that? You just go to your data. When you go to your data, you see data analysis here. So this is tools for financial and scientific data analysis. So they have financials and scientific data analysis. So do you have it on your system? Can you go there? So when you go there, you click on this data analysis. So it's called the two pack in Excel. So when you look at that, you have the ANOVA single factor. These are two packs analysis tools. We have ANOVA. This ANOVA means analysis of variance. Okay, this is two factor with replication. So don't worry. There is this correlation, this covariance, this descriptive statistics, this exponential smoothing. This is Fisher's test, which is called F test. This is Forens analysis. This is histogram, moving average, random number generation, rank and percentiles, regression, sampling, t-test. We have different kind of t-test. This is paired two sample for means. This is t-test, two sample assuming equal variance. See? Two sample assuming unequal variances. Then we have the z-test. So the z-test is the normal test, which is the we call normal distribution. Okay. So what we want to do here is the descriptive statistics. So what we pick here is descriptive statistics. When you do that, you click OK. So you see something will pump up, and this will give you the input section and the output section. There's two things you see here. This is the input section. This is the output section. So within the input section, you will need to pick where your data is. So when you click on where your data is, this is where your data is. We want to find out the characteristics of the exam scores. So when you click it, so you find out that your exam scores is within F1 to C9. So when you do that, you click on this arrow down, it will take you here. So now you can see this label in first row. So what you're trying to say is that the label, this first row is the label of the data set. So now that is it. So then go to the output section. Now I've done it before. You check this because this is talking about the summary statistics. So when you mean the summary statistics, it means that you want Excel to do mean, median, mode, everything about the data set. So Excel will do everything about data set. So here, if you want Excel to have a new worksheet for you, it will do that. If you want to input your value in your set, that means in the Excel you have. So you just click on this and click here. So A1, so I want Excel to put the result in A11. So I'll click that. So it will put my result in A11 for me. So you see that those values have been pre-picked before. That means the largest, the K1, Kent, and the largest, the smallest one, and the confidence level for me. So normally it is 95%, which is 0.05 confidence level. So with this, you click your OK. So when you click your OK, you see the result here. So this is the scores. So eventually, your mean has been calculated. So here, Excel saying that the mean of our exam score, see this is the exam score, is 76.75, and the standard error is 4.8, and the median is 78. So the mode is no figure because mode cannot be calculated. You can't find mode here. Okay. Now, and the standard deviation is this. The sample variance is this. So there are some things here we don't need, or you don't need actually. So kurtosis. Kurtosis is the level of the thickness of the distribution. We have what we call the mesocortic, we have leptocortic. So the next one is the skewness. So we have two types of skewness. We have negative skewness and the positive skewness. So, but this so is what it's telling us here is that the distribution is negatively skewed, but we don't need that. So this is the range. Okay, this is the range. What the range is, the maximum minus the minimum. So when you subtract the maximum number, subtract it from the minimum number, that is where you get the range. Okay. The maximum number is 95 and the minimum number is 55. So that's 40. So the range is the difference between the maximum number and the minimum number. So the sum is addition of all this. So when you add it up, you see that you get 614. So that's what he has done. Then the count is counting the numbers of students we have is 8. So that is descriptive statistics. Do you have any question?
Yes, sir.
Question, please. Can you ask your question?
Sir, I got confused from that data, from that explanation. Everything you explained about how we arrange that data, I didn't get it. I mean, the differential statistics we did now. The method you use, I didn't get it very well. Hello, can you hear me, sir?
Hello, Paul.
Hello, sir.
Okay,
I said,
okay.
can you hear me?
Yes, I can.
Okay. I said for that data, the way we got the arrangement, like from the differential statistics there, I didn't really get how you come about that one. I don't understand it. It's not clear to me.
Okay. Please, I want everybody to talk. Is there any other person that has something to say so I can go back and explain again? Don't keep quiet. Oh.
Okay, sir. Like I always ask, like if you can just run over it the second time, so that we can. That's
Okay.
it. Yes, sir. Thank you.
All right. Who else? Mr. George?
When you were explaining all those data, I don't know whether it's my own network here. The thing your page didn't show, but I was hearing all your talking. But when you ended, the thing now came and I saw everything, the analysis. So I will request if you can go over it again so that we follow you clearly. Thank you.
Okay, Mr. Aransiola.
I will need someone to reshare the data set on the group because I don't have the data set.
But as you are seeing it, you can type it as I was sharing the figure, you can type it from it. You can type. Okay, let me go back. Let me go
Sorry,
back.
sir. The data set is there on our Telegram group. It's not far, it's there. Just go there and download it.
I checked it, I didn't see it. In fact, I'm just opening my I'm just opening my listing for today and I can't find it.
It's one of the last messages they sent today.
Okay. I think the problem is the new data analysis group. It was sent to the new data analysis group. So I don't know. Maybe you can repost. You can forward it, Shiri, or maybe join Mr. Resola. You can join the new data analysis group. Then you forward the asset first. Thank you.
I already joined. Thank you.
All right, let's just You can also pick the figure from what is not much, it's just 8 lines. So let me just start again and let's see. Okay, let me go. Can we all see this now? Nobody's talking to me.
Yes, sir, we can. I can.
Yep.
When I was asking, did you see it? Nobody said anything. Or Mr. Just said he did not see anything. So this is the data set. This is the data set. Okay. Now, this data set. Okay, we just share the data, please. You can get it now. So this is the data set. And the data set is having a student line numbers, which is the serial number. We have the study. We have the study hours. And we have the exam scores. So what we, okay, let me just delete this again. Let me delete it. Okay, this is the student, this is the study hour, this is the exam scores, this is the gender. So we want to find out the descriptive statistics of the exam scores. The descriptive statistics of the exam scores. So the exam scores is 55 and 63, 70, 74, 82, 85, 90, and the last one is 95. I'm taking it slowly so that we will understand it clearly. So we want to look at descriptive statistics. And I said again that descriptive statistics is the summarized characteristics of a data set using the mean median, the standard deviation, the standard error, the maximum and the minimum, and the range. So it will tell you all the characteristics of this data. It's like seeing someone now and you want to know everything about the person, the height, the states of origin, the marital status, the educational level, and so on and so forth, the position in the family. So the same thing descriptive statistics does for data set. So the word descript means describing. So describing the data set, that's the meaning of descriptive statistics. So Excel can do that for us. How do we do it? Just go to this place, data set. When you click data set, you will see data analysis. Click the data analysis, you see this pump up. The analysis tools. It's called the 2-pack. So in the 2-pack, these are the 2 packs. So you have all this in the 2 packs. So many things are not here that you find in SPSS. So in the difference between here is that there are so many things that are not here that you find in SPSS. But like someone that does not really do so much about data can also make use of these analysis tools. So what we want to do is descriptive statistics. You look for it here. This is it. So when you click on it, then you click your OK. So when you click your OK, you see a descriptive statistic box will pop up. And this box is in 2 ways. You have 2 boxes here. You have
I can't see what you are doing, Sal.
If you cannot see, then check. That means you are using your phone.
I'm using my
Hello?
laptop.
I'm
You
not
are
using
seeing
phone.
me.
I'm using my laptop. And we are not seeing what you are doing. I only saw the Excel sheet.
Oh, you are not seeing.
I can't
Okay,
see.
let me reshare.
It's not,
Let me
we are-
reshare.
okay, thank you.
Let me reshare. That's why I want us to talk. If you can't see, talk. Don't just be looking at me. Please, can we just talk when you can't see? That was why I want us to be talking. Can you see now? Can we see now?
Yes, we
Yes, sir.
can see the data. Now we can see the data.
Okay, you can see the data now.
Student hour, study hour, exam score, gender. That's what you can see.
Okay, okay, no problem. If you can see this, we can continue from here. So what we want to do is the descriptive statistics of the
No.
exam scores. So the descriptive statistics of the exam score will show us every characteristics, as I've said earlier. So how do we do that? You go to data, you click on this. When you click on that, you click on the data analysis. Can you see the data analysis box?
Yes, sir. Yes, sir.
So that is the analysis tools box. It's called the tool pack. Now, in this analysis tools, we have different kinds of analysis here, tools that you can use. And I said before, and I'm saying it again, that we have different. In SPSS is more than this. In SPSS, you see different tools, more than this. So now what we want to do is what we are going to look for. So I will look for data descriptive statistics. So this is the descriptive statistics. Then you click your OK. When you click your OK, can we see the descriptive statistics box?
Yes, sir. Yes, sir.
Thank you. So in this box, we have two boxes here, the input and the output options. The input is this one. So input means the data set you want to consider. So the data set you want to consider is what you have here. So when you click on this box, you click on this arrow. So this arrow will tell you pick your data set from here. So it will pick the C1 to C2 to C9, C1 to C9. That's your data set. So when you do that, you click this to bring down your descriptive inbox back. So this is the input range. Now, you know that when you pick that, you will pick exam score. So you label in first row. So what we are trying to tell is there is that the first line is the label, which is the exam score. So we are done with that. So we move into your output box here. So you want this output to come into this place. So when you click on check on this, we said, though, I want to put it in my new Excel sheet. You click on this. But if you want to put it on the same place you have your data, when you click on this, you click on the cell. So that means that your output will come to A11. So after that, you click in your summary statistics. So what we are trying to say is that Excel should analyze everything about the data for us. It should do everything, every characteristics about the data. So when we have clicked on that, we are fine. So the next thing to do, you see that the confidence level has been picked already. This has been picked already, so we don't need to uncheck it. So you just click your OK. When you click your OK, you see the score, the results will come out here. So in this result, this is the mean. So when you look at it, this to this, you find out the mean. Look at this. What's the mean here? The mean is 76.75. So this is the mean. So you have got, if the mean is there, so it calculated also the standard error for you, then the median. So the mode not calculated. I will ask us why is this mode not calculated later. I've said it before. So the standard deviation is this 7.6, 13.6. Then this is the sample variance. Now, this is the kurtosis. So, and I said that kurtosis, we have different kind of kurtosis. We have mesocortic, leptocortic, and other cortic. I will remember later. So we have three kinds of cortic. So leptocortic is the highest cortic. So what does the cortices means? It means the level of the peak of the distribution. So, but we don't need that. Don't disturb yourself with it. So skewness is also means the shifting of the distribution to the normal distribution. So we have, is it that the distribution is positively skewed or negatively skewed? So this minus shows that it is negatively skewed. Now the range. You don't need to do to cram all these things I'm saying. Just know how to solve this issue with your Excel. The range, and I said that the range is the difference between the maximum number and the minimum number. So you look at it, the maximum number is 95 and the minimum number is 55. So when you subtract this, that means when you subtract the maximum number from the minimum number, you are going to have 40. So that's where the range. So in the range is also measure of dispersion. Okay, what we did in our mathematics class in secondary school. So the sum, we always know the sum. The sum is always, when you want to use the sum, you can make use of the sum. Was the sum function. So when you calculate this, you find out that the sum is 614. But by doing the discrete statistics, that has been done for you. So the count means how many students you have there, A students. So you can also make use of your count A as what we learned before. When you make use of count A and count this, you find out what you have, that it is what, 8. So this is not necessary because Excel has done that for you. So this is the total description of the data set, which is the exam score. Is that clear now?
Yeah,
Yes,
yes,
sir.
it's clear now.
But the screen has stopped showing.
Okay. Now, who can tell me why is it that the data did not calculate the mode?
Because it doesn't exist.
So what is the mode?
The mode which is supposed to be the most occurring figure, it's not
So
there.
the most
It's just
The
correct
highest
figure.
frequency.
So that means that no number appeared more than once. That is why you are saying this in this place. So that is it. So fine. We
Your
said
screen
we
is
all
up.
have the data set. Who are there any other question before we move on? Any other question before we move on? So I have a classwork. Who can calculate the descriptive statistics of the study hour? The descriptive statistics of the study hour. Who can do that for us? Calculate the descriptive statistics of the study hours. So we want to know the mean of the study hour, the standard errors, and all that using your Excel. So who can do that for us? Based on what we have done. But we all say it's clear now. So since it's clear, so somebody has to do that. I will call your name. Should I call your name? Victory is not in this meeting. Okay, Florence is here. Okay. Okay. Okay, Precious is here. Precious, you walking like Nicodemus. You are welcome. Okay. Who is doing that for us now? I'm waiting. The descriptive statistics of the study hour. Okay. Mr. Femi Sholeye, can you do that for us? He's not there. Okay. Let me call someone else. I won't call my normal people. Okay. Florence Aliba, can you do that for us?
No, sir. Just joined the class few minutes ago.
No, that's okay. Your excuse is accepted. Okay, I'm calling Beatrice. Beatrice,
Sir, uh, thing is, I'm not using my laptop. It's not charged, but I can run us through the process. If I
don't
miss anything, someone rescue me. Oh.
don't let us run away. We want to see your work. We don't. You want us to run away. If you run us through, want us to run away. Hmm? Okay,
Yeah.
blessing, blessing. What is your excuse? Blessing, blessing. So I'll make that. I'll keep that for you. We don't waste our time. So after that, we want to go into another thing. And after we've done this descriptive statistics, so we want to look at correlation. We want to look at correlation. Okay. So correlation. So, and I said earlier that correlation is the relationship between two what? Two variables. So correlation measures strength, direction of relationship between two variables. Now, this correlation will show whether they increase, they decrease, or more independently. So, meaning that when there's no correlation between two things, it means they don't have anything, any relationship. So, there are two independent variables. So, the relationship between them shows the correlation they have. So, that what they say, there's no correlation between that girl and the boy. Okay? So, and their condition, which is also the assumption in correlation. We have the Spearman correlation, we have the Spearman ranking. So we have different kind of correlation. Okay? We have different kind of correlation, and we need to take note of that. So when the figure given is not the one that you can use, you can calculate. You can only do that by ranking. You make use of the ranking correlation. Okay? Now, the condition is this. When the answer, which is the small r, look at it here. That is when the small r, which is representing correlation, is equals to +1. It simply means there's a perfect correlation between these two variables. But if it is -1, that means there's a perfect negative correlation between two variables. So the positive means there is an upward line, which is an increase. The negative means there was a downward line, which is a decrease. Also, the way we did for descriptive statistics, and we can say that this 76.75 is the average exam score, which ranges from 55 to 59. That's the way to interpret it. And spread moderately between 13.72. The same way we are going to interpret the correlation. So when the value is less than or equals to 0.5 positive, it means a weak correlation, a weak positive correlation. Don't forget, when the question, when you have plus 0.5 less than or equals to, less than or equals to, this simply means is a weak positive correlation. But when you have positive, this less than, sorry, less than or equals to, but when you have greater than or equals to plus 0.5, this is a strong positive correlation. So from this up, so this is how to analyze it. One, I said we have perfect positive, which is +1. So the +1 is perfect positive. So this is the perfect positive. So this is perfect positive. So the same way we have for the positive is the same way we have for the negative. So we also have perfect negative when it is negative. So this is the perfect negative when it is equals to -1. So when it is less than or equals to minus 0.5, that is a weak what? Positive. So negative correlation. That means that the relationship was not that. So this is the negative. So we change it to negative. And the same way, this to negative. Okay, let's change it to negative. So this is negative. So this is the explanation of the figure. So when you have the figure now, you will see how this will play out. So the analysis of what we have depending on the result of what we are going to receive at the end of the day. So now, when you want to look for correlation, you have to consider two variables that might likely have a relationship. Now, the study hour and the exam is possible to have a what? A relationship between them. So we want to find out, is there any relationship with how people study and how they receive their result comes out? Is it the way they study shows in the scores they have, or there's something else? So that's what we want to find out. So now we want to make use of Excel. So the same way we go to your what? Data. So I'm now there. Click on your data analysis. Then look for correlation. Look for correlation. Look for correlation. This correlation here. And click OK. So when we click OK, we are going to put again the input range. So this is the correlation in box. We are going to put the input range. So the input range is the data set we want to put in here. That's the input range. So what is the data set we want to put here? We want to put the
Hello,
study.
sir. Please, your network is breaking from my own end very seriously.
I'm not
Hello,
sure.
sir.
Are you hearing my voice, everyone?
Yes, sir.
It's
Yes, sir.
breaking. It's breaking seriously.
It's breaking.
Can you Can you hear now?
Yes, sir.
Okay. Is Nigeria, our network is we are managing the network actually. So let's manage it. So fine. This is the input range. So we want to put the study hour and the exam score. So we have to click on this. So it's picking from the study hour to the exam score. That is our in the range of the data. So the next one is this label too. When you check this, it simply means that you are telling Excel that the first line, which is the label in the first row, the label in the first row. So as is on, you click on it. So the range is where you want the range of the output is what you want the data to be. So I want the data to be here, but that's not where it's supposed to be. We'll pick that later. So this is what we picked earlier. After that, then we come to our range. So where do I want the data set to be? I want it to be here. So
Sorry that I have to interrupt you.
A28.
Sorry that I
Don't
have to
interrupt
you.
when we are through. Don't interrupt, please. When we are through, I will ask a question. So we put it on A28. Then after that, we click your equals to that. So this will give us the answer to what we have. So we are going to have a box of this. Now this is showing us 1 here. This is showing us what 1 here, but this is showing us 0 point what. So when you see this label, so in this we are going to have study hour and exam, study hour and exam. So this is study hour and study hour. So the relationship will be perfect. This is exam and exam. The relationship will be perfect. This relationship here is between exam scores and the study hour. It is 0.994003. So from what I have here, somebody can tell us what the interpretation will be like. So before that, can I hear from Mr. George?
Thank you for giving me the opportunity. You are the one who
Please,
used to tell us.
Excuse
You
me.
used to tell us that if something is wrong, we should alert you on time.
Okay, what is wrong?
The screen you are showing us, there are multiple screens that makes what you are teaching us not to be visible. If it is single screen, it will be very clear. There are just multiple running into series. So that was what I wanted to tell you.
Okay, let me see now. What about now? Can you see one screen?
Yes, sir.
Okay. Now can we go back again and explain it in case something was missing? Should we go back again? So let me go back again. This is the data. This data analysis. This correlation. Pick on your correlation. Now you pick on your range. So this is the range. The study, want to find a correlation between the study hour and the exam. You pick the range. So it's picking for B1 to C9. B1 to C9. So after that, we check in our label, which tells us that the first row is the label, which is the label of the data set, the study hours and the exam score. After that, we come into our output range, meaning that where do you want your data set to come to? We want it to come here, so which is A28. So after that, we are fine. Just click your what? Okay. So this 1 and 1, it means study hour and study hour. So we are looking relation between two the same thing. It will be perfect. Two the same thing here will be perfect. So the correlation between the exam scores and the study hour is 0.994003. So from here we can interpret this thing, this figure, using what I have in this place. So using this assumption, what can we say the relationship is? Can someone tell
Strong,
us?
strong positive correlation.
So can you make it a statement? Turn it to a statement.
The data analyzed can actually be, be classified as a strong possible relationship between the study hours and the exam scores.
As a data analyst.
Okay, can I give it a try?
You can, please.
Okay, I'd say that there's a strong correlation between the study hours and exam score. A positive, a strong positive correlation. There's a strong positive correlation between the study hours and the exam score.
A perfect positive,
Can I say
Can
a perfect positive
positive
correlation between the study hour and the score?
Now, that is 0. I did not
I
say.
can I say
I did not.
something?
Okay, who is saying something?
Can I say?
Who?
I'll say from my own end, I'll say that from what we deducted, you can see that the study hours affected the result, the scores of the students, because their relationship is that the study hours, the input of the hours that the students took is what that affected their exam scores, because the more they stay in their study hours, the more they have a better result.
So, based on, don't forget this assumption. Jonathan, anything?
Okay, sir. I'm saying this this strong positive correlation and strong negative correlation, they're having the same value.
But it's different signs.
Greater than equals to plus 0.5 for strong positive, and greater than
Okay.
equals to plus 0.5 for strong.
Okay, this is supposed to be minus. This is minus. Sorry. You should know that this is minus. So that is minus. Is that fine now? Is that fine now? Jonathan. Okay, who else?
Yes, sir.
Come on. Anything else?
I'll say the correlation between study hour and exam score is a strong positive correlation.
Okay. Okay. For others, now there's a thing you need to find out here. When we are doing correlation, you don't approximate. Oh, you don't say it since it's 0.9. Yes, it's 1. It's a lie, it's 0. So the condition is this. You don't approximate, and there's an assumption that it is between -1 less than or equals to R less than or equals to +1. This is the assumption. Oh. Look at the assumption. Can you see the assumption? This is the assumption of correlation. So it won't exceed -1 and it won't be more than +1. If you calculate your regular correlation and it is 2, it is groundnut. Oh. Complete groundnut, and you are the one that will eat it. So when correlation is more than 1, I don't know, it is groundnut and bread. Just start eating it. So the condition is clear. So that is why you have to understand that this figure, you don't need to approximate it. So 0.009. So when you try to approximate it, become 1. And you say it's positive, perfect. You speak that fine
Okay.
English. 0.
Okay, sir. So sorry, sir.
I scored 0.
Can we say it's
Can
increasing?
we say something now?
The correlation is increasing.
Yes, it's increasing because if you look
Yay.
at it, when we get to regression, you will see how it will increase. There is regression. That is when we look at the intercept and the slope of that intercept in the model. So somebody say correlation is more than one. Jonathan, you say will be more than one.
No,
Hello,
no chop
Jonathan.
groundnut and bread o.
I
Correlation
want to
must be
say
more
must
than
not be more than one. Sorry. Sorry.
please.
Must
It
not
should
be.
not be more than one. No, that is the assumption. The assumption is clear. If you are doing your project and you calculate your correlation and your correlation is more than one, just know that your supervisor will cancel it. And there's a formula for correlation. Normally, if you are doing your correlation, there's a formula for it. But we don't have time for that one. So the interpretation of this is that there is a perfect correlation. There is a strong positive. So there is a strong So there is a strong positive correlation. So some of you, after this class, you can start doing project for people. There's a strong positive correlation between strong positive correlation between the study hour so between the study hours and the exam scores. So what it simply means is that the more they study, it will be the more they perform well. Now, let me tell you the truth. Statistics does not go against the normality. So it's not something you can maneuver. It is, or if it is otherwise, that simply means that that scores the figure. So if you make an interpretation that is not well normalized, now look at the interpretation now. If your interpretation says that there's no correlation between the study hour and the scores, that simply means that eventually the student did not study and the end product is that there was an exam malpractice. So statistical analysis is something that can give, at the end of the day, questions. People might not be asking that where is this thing coming from? So if the interpretation is not normal, that means something is wrong. So if at the end of the day, your interpretation is, or your result is negative 0.99, so therefore, what you are trying to tell us is that they did not study and they passed. Oh, so what happened? What is the factor responsible for these exam scores, high exam scores? That is what the question will be. So there will be another study to show that. So simply means that there is something else responsible for this exam score. So that is the reason we are going deep. So any question before we go to the next thing we have, which is regression?
Sir.
You can raise your hand. Raise your hand so we can call you. Raise your hand, please.
Hello, sir.
Raise your hand. Let's know people that ask a question. We'll call you. Who want to talk? Raise your hand now so we can call. You're not raising your hand now. Okay, Paul. Paul, you can talk now.
Yes,
Paul, you can talk.
I'm having challenge here.
Okay.
Can you hear me, sir?
Yes.
Yes, my challenge is not even my own challenge is from the Excel. Is it different? Because from my own, when I open my data set, I click on data. I'm not seeing this section of data analysis.
Thank you.
I don't know
I
what
wanted
happened.
somebody. I wanted somebody to say it because I know that some people here will not have that in their Excel. It is because you have not activated it yet. So can we do it together? Who else is having that challenge? So I can show you how to do that. Can you check,
I am
Mr.
having
Ransom?
it. I'm having it.
Okay. Let me tell you
I'm
how.
having it too.
Okay, let me tell you how to do that. So go with me. So when you this is your Excel. So go to your file and go to your option. When you go to your option, you will see this pump up. Can we see that?
Sorry, sir, I didn't get it.
Okay. Go to your Excel, normal Excel like this. And
Okay.
go to your file. Click your file where you see your info, new, open, save
Yeah.
as. Go to option.
Yeah.
When you click your option,
Okay.
you see this come out. Can you see that? So
Okay.
when you see that, you click your advance. So can you see advance?
No.
You can't see advance. Can you see general? Can you see adding?
Okay.
Can you see adding?
Add in.
Yes.
Okay, now when you see adding, then click on this. You see
Yes, I've
Excel
seen
adding.
addings.
You see Excel adding, right?
Yes, I've seen as addings.
Okay, do you see analysis 2-pack in this location? Do you see analysis 2-pack? Check for analysis 2-pack. You see it in the first one. Analysis 2-pack VBA, which is the Visual Basic Analysis. I use that, and I don't know what others don't. So when you click on it, when you see analysis 2-pack, the first one, can you see that? Is in the library of your Microsoft Excel workbook. Microsoft Office. Just click on the, please, can somebody answer me? Can you see this analysis 2-pack?
Analysis 2-pack, Abby. Inside add-ins.
See it here, yes, inside add-ins.
Yes.
So click on it like this. So if you want to get your
Yes.
VBA, you can. So I use VBA. So if you don't want to use it, you can click on this. So when you click on that, then you go to OK. Click your OK.
So I should use the VBA now.
No, you are using your 2-pack.
Okay.
Excel 2-pack. So when you click on it, then click OK.
Okay. But someone can actually choose more than one now.
Please, can you do the 2-pack first?
Okay.
Have you done that? So then you click
Yes, sir.
OK. So when you click OK, so go to the data again. Can you see it there?
Yes, it's out.
Yes. So who else
Thank
got
you.
that? You are not talking now. Later you tell me you have issue. Who else has any issue with that? Do we all got that?
It's like I'm
Yes, sir.
having. I've got to manage Excel add in. I should click on it.
Wow. So do you expect me to do it one after the other?
No. I just want.
I have done it. So let's go again. Please, can you go again? when you go into Excel, click on your file, go to your option. When you click your option, go to add-in. When you see analysis 2-pack, click on the 2-pack. Click on it and click OK. When you do that, then come to your data. You will see data analysis in this place. Have you done that?
I've done it.
Can you see it?
I've seen it. I've seen it. At this corner. I've seen it.
Who else is having the
I've seen
issue?
it.
Who else? Are we all fine now? Are we all fine? Can we go on?
I've gotten it.
Yes, sir.
Can we go on? Can we go on?
Yes, sir.
Answer ahead, sir.
So let's go on to with that. So we have so the next one is the regression. So we want to look for regression. So this is regression. Now, regression analysis is one of the things that is very, very deep. But we are going to be looking at that too, our regression analysis. So the regression analysis is when you want to look at the predictive value when you have a dependent variable based on one and more independent variable. So we want to when you want to estimate the relationship and quantify their statistical significance, that is when we make use of regression. Now, there's a model in regression, and the model is y equals to a x plus b. This is the model of a linear regression. Now, let me just change this to capital letter. This is, I would like us to go with me. So this is this, where your a, your y is standing for something, your a is standing for something, your x is standing for something, and your b is standing for something. A linear regression. Your y is the independent variable. Is the independent variable. Y, our a, is the slope. And your x is the dependent variable. Is a dependent variable. So, and your x is the intercept. Now, the explanation of our regression, intercept, okay? The explanation of our regression can be further stressed with regression. The explanation of our correlation can be further stressed with our regression. So we want to also find out if there's a correlation between two things, what kind of correlation they have. Is there any linear or cubic or any other way relationship? So when we want to consider two things in regression, we want to find out, classify it. One should be a dependent and one should be independent. Sorry, this is dependent and this is independent. So the independent is the one that can stand alone, and the dependent is the one that depending on the other one. So an increase to the other one will bring an increase to that one. A decrease to the other one will be a decrease to this one. So from this data set, what is our dependent? Who can try? What is our dependent? Who can try what a dependent is for us here from this data set?
That would be the. Uh,
You don't like raising your hand, Beatrice.
Sorry, sir.
And this your network. Okay, you can talk, please.
So the study hours. I mean, the exam score is the dependent variable.
Great. The exam score is the dependent variable. So there's the exam score is a dependent variable. And the slope, we don't know. What the dependent variable eventually is going to be the study hour. So what it means here is that if you cannot well allocate these variables, I am happy to announce to you that your analysis will be wrong. Because when you are analyzing a particular figure in any way, whether it's correct or not, the tools will give you an answer. But the allocating of the absorption is very important. Okay, now how can we make use get a regression from this using our Excel? How do we do that? The same way, we click on this. When we click on this, we look for our regression. This is the regression. We click on regression. So I've done this before. So we have to input as usual. So the input is this. We have the Y range and the X range. So when you see your Y, so if you don't know what your Y is, what you ask yourself that which one is Y again? Which one is X again? So the Y range means the dependent variable. So you are going to pick the dependent variable. And don't forget what dependent variable is. This is your dependent variable. Then the next one is your X, which is your independent variable, which we have classified to be the study hour independent variable. So C1 to C9 is the dependent variable. B1 to B9 is independent variable. So we put the label, meaning that we want him to label the study hour and the exam scores at the label. So we pick your confidence level. Then the output range. Where do you want it to give our output range? So we want it to put it here. So we put it on A42. Now, there's residuals. These things are for statisticians. We have residual plots. That means we want it to give you different kind of plot. So I will let us tell him to give us a line fit plot. So this line fit plot is just not going to be a scatter diagram, just to tell us what kind of relationship does it have. So it's a line fit plot. Okay, we just pick the line fit plot. So we click equals to. We click OK. Now, when you click OK, you see the summary output. Now, when you do your regression, there are three things that Excel will do for you. Either Excel, either SPSS, or which other one. They will do part of correlation. They will do ANOVA, which is analysis of variance. And they will do a coefficient and standard error, which is the regression itself. So in this place, this is and this is the same. So what is the meaning of all this figure here? I will need to explain one after the other. And can you go with me? So this is the normal, our what? Our correlation. This is the correlation. You know, we have the correlation before. So this is the correlation, and this is the plot. So we was able to give us the plot. This is the plot. Okay, this is the graph that Excel drew for us. This is the static diagram. So, you know, somebody said the other time there is a what? Increase. So if you look at this graph, you can see there is an increase. That is, as the study hour increases, the scores of the student increases. Can you see it? As the study hours increases, the scores increases. So there's an increment. So let's go on with this. This is the study hour and the scores, the exam score correlation, which is 0.9999 and all that. This is the R square. So this R square means that the explanation of the what? Of the dependent variable to the independent variable. And vice versa. That means that, so this is calculated in percentage when you want to interpret it. So when you want to interpret this, you calculate, you pick it to percentage. But that's not what we want to do. So I just want to teach us in case. So what we are saying here is 99% of the exam scores can be explained by their study hour. That's the meaning of this R square. So when we look at that, what we now ask for is what's the remaining? So 1% is other factors. That's what we mean. That 99% of the exam scores is due to their study hour. Why 1% is other factors? We don't know. That's the meaning of all this rubbish. Now, the ANOVA is analysis of variance, which is by features analysis. So this is called features analysis. So there's a man called Fisher. He's a renowned statistician that brings about analysis of variance. So it's the features, as you see, it's called F distribution. Feature analysis, or we call it the F distribution. So I don't want to go into data analysis, sorry. So I'm just trying to tell us what this thing stands. So we are not making use of this. So this analysis of variance is used to test whether the regression is significant or not. But since we are not going too deep to that. So what we are going into is just this. So I told you the intercept, what the intercept is, and I told you what the hour is. So this study hour is the slope, where this is the intercept. So if you go back to our model, we can complete our model now. So what is our y? Our y is what? The exam score. Our y is the exam score, which is equals to, what is our a? Our a is the slope, which is what? 2.78. So this is 2.78. And what is our x? Which is x, right? Then plus, what is the intercept? The intercept is 51.6. So 51.6. So this is the slope now. This is the regression. So what does it mean in this place? So this, let me explain. Some people might say, what is all this? Now this lower and upper confidence interval is telling us the line between where we got this intercept. So when you add this together and divide it by 2, you find out the answer will be this. So you see the average. It means that what this means is that the intercept fall between this range and the slope fall between this range. That's the meaning of that. So this p-value is what we use to calculate, to find the significant value between this and this one is the table. We want to find your table. So what we use, we compare this thing between 0.05, but we don't need it. Just if you need more explanation, we'll go to that. So that's when you set your hypotheses and all that things like that. So now this is what I want to explain. This is the model now. So from here, you can see that number one, the slope, which is 2.7, is positive. That means that this thing you said here is true. If this guy is positive, and the slope here, which is 2.7, is negative, is wrong. So that is what most times your supervisors is checking, that your correlation is positive, but your slope in your regression is negative, is a lie. Because you have told us that the regression is going up. So why do you now get a model that is negative? So for now, we are correct because this is what? Positive. So what we are saying is this. Don't forget that your X is what? Your X is what? Study hour. Our study hour. So what we are saying in this, what you are telling us is that for every 1 minute hour study, for every 1 hour study, 2.78 will be added to the student examination score. So in as much as the hours keep on increasing, this score keep on increasing. That is what the model is talking about. I'm just trying to explain the model, not just you getting the answer, but explaining the model, what the model means to us. So there are some other explanation that I would not like to bore you with. So that is how to calculate your regression. So many people are raising their hand now. Okay. Beatrice, Camo, can you talk, please? Who is talking
Sorry,
first?
I did not bring down my hand. Sorry.
Okay. Okay. Do you have any question? Any question, please? Or am I going deeper? Jonathan.
So I don't know. My network has been going on off and on. I just hope this class will actually be posted on the YouTube so that we can go over it and learn ourselves instead of taking us back. All right.
Eventually it will. Eventually it will. Okay. Mr. George. Okay. Sorry, come on.
My okay.
Let's hear from
Um,
Camo, please.
so actually, I've missed a few classes and I don't really understand what's from the summary output. I don't understand from that side.
Okay. You missed some classes or you missed this class. So part of this class.
I missed the class before this one, yes.
No, this we are just starting this today. So this is just a fresh class. So
Okay.
yes, this is a fresh class. But that will be posted on YouTube. That's why we want everyone to be part of that YouTube. Subscribe, like it. So when we have a new video, you can pop up and check. Not only checking comedy. Some of you subscribe to comedy, subscribe to all that. Nobody asks you to. This thing you have to subscribe so that you can get it your notification when the video is already uploaded into the video. So that.
Okay.
So for now, your data on your phone should be kept for learning alone throughout this period. Just an advice, actually. Mr. George.
Yes, this is an interesting course. I want us to. I'm asking, how do we use it to make money? Because if you rack your brain like this, you should be able to put something in your course. That's my question.
Okay. All right. Who can answer that question? Because I have a question. Mr. George. Okay.
Yes, I'm hearing you.
All right. Okay. This thing, how to make money. But I think when it comes to data analysis, is a career. Is that not?
Yes,
Hello?
accepted.
So a career is something that will carry you. So eventually you are making money from it. So you don't need to have another way to do that. So with a data analysis, a data analyst, you what you need to analyze, you call yourself data analyst. So you need to know all this. So it's a career. It's like asking a lawyer, how does he make money? He's a lawyer. So if you have case, you come. Hmm? So if you have issue like this, you will come. Hmm? That's why someone said that skills are more than strength. So when you don't know it, you don't know it. So when you know it, people pay for their what they cannot solve. So how does it make you make money? Is when you know it. Somebody have an issue you cannot solve. So you solve the problem and you get your money. Simple. So who else is talk want to say something? Beatrice, are you raising your hand or just still now?
Yes, sir. So
Okay.
I heard you say that the outcome, one of the outcomes can be wrong and the other one right. Like slope. Here you mentioned the slope can be this or that, and the other one
No,
can be. So I mean,
no.
what will cause
What I'm
that to
saying,
happen?
what I said was, hello? What I
Yes.
said was that there is a way to check your correlation with your slope.
Okay.
If this correlation is positive, this your slope, which is 2.78, must be positive. If it's not positive, it's wrong.
Oh yes, sir. So that means there is a case like that where it
Yeah.
can be wrong.
If it's
Yes.
wrong, that means that you didn't allocate your dependent variable and independent variable very well, or something
Okay.
is wrong with the data you input there. So you
Oh,
can't tell us that there's a correlation between that, and therefore there is a negative here. So your interpretation will be wrong.
okay, sir.
Because if this is negative, no matter what your study hour is, this negative will will reduce it. So that means there's a reduction. And you told us here there's a positive relationship.
Okay, sir.
Mm,
So my second question.
okay.
In real life situations, so we have everything, the outcome correct, but let's say, um, let's say by from what you have said, um, let me get my question straight. Let me go back to where I wrote it. Sorry.
Any other person can get your question ready at one side.
Okay, yes, sir.
Okay.
So
Who else?
I want to ask from the very start from the very beginning we've started all this and to this very part now. When do we say we are data analysts? That's first question. And does like for instance, I tried getting some data set on Google, and I don't know, is there a way or is there a particular data set that requires this correlation, regression, and the rest, or is
So,
something that the organization gives us to do?
okay. Let me just come to that. When you are working in an organization, you learn on the work, right?
Yes, sir.
And the more you are able to solve the company problem is more relevant you are. So the problem they test you when you are doing your interview is not the problem you'll be solving. There are more problems to solve. Let me give you an instance. My former company, we had issue with, we have two brands. And our two brands have different management, but we used to open them in different places. And the same places, sorry. Some in the mall, some standing alone. Those that are standing alone, some of them have the two business together. One was selling ice cream, one was selling burger. Are you with me?
Yes, sir.
So there was a sales breakdown, and the people that are selling ice cream demand for branding and their marketing mix. So as an organization, we want to find out These two brands, they are all, we have like 5 of them across Nigeria, which they are close to each other. We want to find out, is there any relationship between their customers? Are they sharing the same customers? The problem we have in Nigeria is that they teach us something now, but there's no application to that business. Nobody told me I'm going to do that when I go to that organization. But when the management was having problem, so I have to take them back to analysis, because nobody could explain that to the management. So how can they get this fact? Are these two people, because this is it, are the customers coming to buy burger are the same ones coming to buy ice cream? Or do they have their own customer on their own? Even if they have their own customer on their own, what's the relationship between the sales they make every day? That's when all these things come up. So if you are in the data analysis of the organization, what will you do? Will you go and stand at the gate and start recording the numbers of people that come for sales? So if this question is asked and you are the data analyst, what will you say? So the ability to bring in the problem and use your data sense to solve it makes you a data analysis. To know the tools applicable. It's like when you get to a tailor and the tailor will just bring out screwdriver and using screwdriver to measure you. You know that this person is mad. You will just leave the place. No matter how, even if they tell you that this person is sewing clothes for Yomi Casual, or is one that even sew clothes for Davido, you will say no, because he's using the wrong tools in the first place. Okay, I want to sew buba, I want to sew gown, and you're using plier to measure my body. You know that something is wrong. So the application of the problem is one of the things we say in data analysis. What makes your data analysis? How we were able to think of what to those jargons you now use it to solve a real problem. So by these questions I've said, I was able to come up with a report, a comprehensive 20-page report that states, got the sales of the organization, got the we call it the number count of the customers across within 6 months and 1 year, and there was an establishment that yes, in spite of the fact that there was a relationship which is about 0.56, which shows that because initially we wanted to close one of them together or merge it. So we now found out that those ice cream brand have customers on their own. That we have customers that comes around to buy only ice cream. So by that, the managers have to say, okay, let's give them a new manager. Let's give them their own branding themselves. So they don't let us merge the brand. Now, all of us know Unilever. Unilever is having different kind of brands. Every time they make their market research to find out that they know that their customers are not the same. Now you have Nigerian bottling company. Why can't they say, we are the one producing Coke, therefore Fanta, we are not producing Fanta again. We are the one producing Fanta now, so why are we doing 7-Up? So all this other one, we don't need it. Let's just produce Coke alone. Because they find out that there are different people that take this thing. They find out the correlations. They find out that if you do remove one, you are going to see somebody that. So in that organization, there are different kind of variables. The customers for Coke, customers for Fanta, customers for 7-Up, which are what? They are the main independent variable to the total revenue they have. So the summation of these sales will give them the total revenue. So when you say, okay, Coke, we don't want again, it's only Fanta reduce, what will happen to your total revenue? You will reduce. Kajiko.
Yes,
Any
sir.
other
Thank you very
explanation?
much,
Any
sir.
other question? So Mr. George is asking how to make money with this. These are the ways company make money with it, and don't lose money also. Are you with me? Hello, Mr. George.
Yes, yes, I'm with you.
So any other question? Beatrice, I still asking question.
So I think that the one that you just answered is already kind of, but let me just put it out. Like, let me read it. So I was going to ask if the conclusion that we always have based on the outcome of all this analysis is always the case in real life, because we tend to like make recommendations, or are there other parameters that could affect our conclusion based on the dynamics in the real life situation? Are we
So
always correct based on this working statistical provisions?
so what will make this not real is when your data is forged.
Okay.
If your data is not forged, the interpretation will be real. So one thing about that statistical analysis is that you can go deeper. And as much as you go deeper, you find out that that relationship that you have established in the first place will be getting deeper. So what does it give you? It will give you the more capacity, more confidence to accept that that thing was correct. So what we do regression for is eventually accept that, yes, truly, there's actual relationship between these two things. So when you find correlation and you say, okay, I'm fine, I don't have problem with that. But we want to go deeper, we go to regression. If you want to go another deeper, we go to t-test and others and others. So these things are deeper things to show us the evidence. So we set hypotheses and we set it right because of type 1 or type 2 error. These things are deeper because some people will say this man is taking us to statistics. So I don't want to be setting hypotheses in this place so that you will look at it that what's going on here. So we have hypotheses you can set up to say, okay, if this is not equal to this, reject HO. If it's equal to this, reject H1. So we have critical regions, we have hypotheses. So these hypotheses will give us, and at the end of the day, their conclusion. So what we do as a data analyst is we have a more confidence to the decision we are making. So somebody can come to ask you, no, I don't believe it, that people that study, somebody can argue with you and say, no, I have people, they can give you example. I have people that study and study and study, they still go to exam hall and their result is not fine. So how can you prove this? And let me announce to you, these are the things where the parameters that the WAEC and others use, when they just look at the center, they will just close the result. You see that withheld, they tell you that the center is cancelled. Because there is a data already. They find out the relationship between the scores of the student and the people that come in there. So imagine you have a center and the people that start the exam, all of them have A1 in mathematics. A1 in mathematics. So you bring that result and give it to them. So that question, there's something is wrong with that. So there are factors that bring out that result. So what data analysts do is we bring out things that are not visible to people. We found out things that are not clear to people that figure can reveal to us. So there's a question Jonathan asked, that when do we become data analysts? We become a data analyst where we can reason beyond figure. There are things figures can show us that we can reason to bring out back decisions that can help us make a very sound conclusion. So Mr. Femi is raising on. Are you raising on, Beatrice? So
No, sir.
Mr. Femi,
Yes,
you can.
I'm just looking at it in terms of conclusion based on the result of the analysis, especially in regards to this issue of study hour and the exam score. What about, could there not be other extraneous variables that could interfere with this prediction? Like, for instance, what about the level of intelligence?
Okay. If you look at this data, hello, can you hear me?
Yes, sir.
Mr. Femi, what's your level of intelligence?
Hello?
What is the level of your intelligence?
I don't know. I've not measured it before.
So these are the words people say they don't know the meaning. So in statistics, we know things. Things can either fall between two things. Either it's a qualitative data or quantitative data. So people say level of intelligence. Who measure the level? They are not measurable. So IQ, you can just say someone have high level of intelligence. So what is the measurement? So we are analyzing what we can measure. So if you are intelligent, we have to show it by variables that is measurable. Say high level of intelligence. How? How do you measure high level of intelligence? There should be a case study. There should be something that's attributed to it. It's like when you say the color of my eyes. What is the high level? What is the color? It is not quantitative. It's not quantitative data. It's a qualitative data. So when it comes to that kind of data, we make use of what? When you want to find correlation, we make use of rank correlation. When we just rank it. So when it comes to ranking, many times in data analysis, when you are ranking a particular data, we don't go to deep analysis because something might be wrong with that. But when we are calculating based on prescription and exact, we make it some measurable. So many times people say, the person has high level of intelligence. Then what is the level? We don't know. So the factors that can contribute to this might be considered, but it's not part of this. If it's one of those things we can consider to also check, like the student, how many students have textbooks to read? How many of them have teachers in the class? Okay, these ones are quantifiable. So we can also check all those ones. Therefore, we are going to be moving from normal correlation to multiple correlation. That means that we are going to consider different conditions that is going to be attributing to our variable. Then we will not go to linear regression again. We'll go to multiple regression. So that is why I don't want us to go too far. So in as much the work is going deep, so for you to be a data analyst, I want to say what I want to answer Jonathan. You must have a figure sense, statistical sense before any other tools. So you must have the knowledge of mathematics and knowledge of statistics before any other tools. Any other one follows before you start doing anything. So it's very, very important. And that's why we are going this direction. Thank you. Any other question? Do anybody have anything to say? Maybe conclusion, maybe something, addition, or anything? Before I conclude on what to say on today's class. Do you have anyone to say something? Okay, Jonathan.
Okay, I just want to appreciate School Global at large and my fellow students for making today possible. And I don't know if any of us know the site Kaggle. For practice, individually, we can download data sets from Kaggle and work with the data set. I think that will help too. That's just an addition. Sure.
It's all right. Okay, I wish you all the best. Don't forget, my assignment is the first one, the descriptive statistics of the working hours. Thank you, everyone. We'll see so I can rest for another class tomorrow.
Get
Then
well
God bless
soon,
you.
sir. Sorry, sir.
Yeah.
Thank you, Mr. Henry. We really appreciate you. You see why everyone for joining class today. Enjoy what's left of your evening. Please check the group from time to time for any information. Thank you. Good night.